In every refinery and petrochemical plant, there is one equipment that does the real separation work, the distillation column. Today, I will break it down in the simplest possible ways. But before I explain the distillation columns, how did the crude oil get to the separation process using distillation column? So remember in my last video, is a video I created titled Crude Oil Pre-treatment and pre-treatment of crude oil. So please go and watch the video to understand the extraction and the pre-treatment of crude oil before we separate the crude oil with distillation column. So I said, how did the crude oil get to the stage of separating its components with a distillation column? So in a brief summary, let me explain it. Remember, the crude oil is being extracted, and once the crude oil is extracted, the extraction of the crude oil means that the oil well is prepared, or we can call it a reservoir well is prepared. So once it is prepared, the oil is extracted. Once the oil is extracted, there's what we call pre-refinery or pre-treatment or pre-refinery. So in the pre-refinery stage, we have in the stage where water and natural gas is being removed for the crude oil. So the crude oil contains natural gas and water. So at this stage, the crude oil, the natural gas and water is being removed from the pre-refinery stage. Then after the pre-refinery stage, we have the transportation, where the crude oil is being transported into the refinery. So it's being transported with pipeline or our tanker ship or even our truck or trains. So after the transportation, when it gets to the refinery, the first stage when it gets to the refinery is called the preheating and desalting at the refinery. The preheating and desalting at the refinery. So we know that crude oil contains a certain amount of salts, which is called sodium chloride. So this sodium chloride must be removed from the crude oil to avoid corrosion. So when we do not remove the sodium chloride for the crude oil, and when we do not remove it and we move it straight to the distillation column for separation, it will make the distillation column to corrode. So it will cause corrosion in the distillation column. So this is very important. The preheating and desalting stage is very important. So after the preheating and desalting stage, we have heating in the furnace. So after the desalting, the crude oil is further heated in a large furnace, typically reaching temperatures between 350 degrees Celsius and 400 degrees Celsius. This intense heat transforms most of the crude oil into a hot vapor gas mixture. So in the heating in a furnace, when the crude oil is heating the furnace, it transform the crude oil to hot vapor gas mixture. So when that is done, they will now move to our distillation column for separation. So the distillation column is used to separate crude oil into their components. So what is distillation column? Distillation column is a separation unit used in chemical and petrochemical industry to separate liquid mixture based on differences in boiling point. So based on differences in boiling point. So it works by repeated vaporization and condensation, allowing lighter or more volatile components to move upward and heavier or less volatile components to move downward. Let's explain the distillation column in a simple tense. Now this is a distillation column diagram. Now we have what is called feed, then we have condenser, then we have the reflux drum, then we have the boiler, then we see the blue and red arrow. Now we see that the red arrow is vapor flow and the blue arrow is liquid flow. Now one thing we note for my previous statement is that the distillation column operates in a repeated vaporization and in a repeated vaporization and condensation waves. So in the repeated vaporization and condensation. So that is how the distillation color operates. It's a continuous process. So once the crude oil is taken to distillation color, it is feed into the distillation color through this point, this feed point. So the crude oil is fed into the distillation color through this feed point. So once it's fed into the distillation color, the crude oil will settle down at the boiler. To settle down the boiler, so the boiler function as eating the crude oil. So the boiler will eat the crude oil to vaporize stage. So the vaporized stage of the crude oil will vaporize upward. So the crude oil will vaporize upward when the boiler has heated it to a vaporized stage. So when the crude oil has been vaporized upward, I can see here in the red arrow. So the red arrow signify the vaporization of crude oil. So we see the red arrow stop at the condenser. So the condenser, there is what we call condensation. Condensation is a state of converting vapor to liquid. Converting vapor to liquid. So at this point of condensation, remember the red arrow signify the vapor state. The vapor state. So at the point of condensation, the vapor is being converted to a liquid. The vapor is converted to a liquid, which is the condensation state. So you can see for the condenser, we represent it with a blue arrow, which is the liquid flow. So at the liquid flow, which is the blue arrow, so the condenser has converted this vapor to a liquid flow. So the liquid will now pass through a reflux drum. So at the reflux drum, the liquid will now split into two. So part of it will be fed back into the distillation column. Part of it will be fed back into the distillation column, and part of it will be produced. That means our product. Part of it will be produced. So and this happen in a continuous process. So in a continuous process, as I said, the distillation column happen in a repeated vaporization and in a repeated condensation process. So we see the boiler does the vaporization state. So the boiler does the vaporization while the condenser does the condensation. So it's a repeated format. So as it is repeated, our product will be produced in a boiling state at every boiling point. So the lesser boiling point product will produce first than the heavier product. So the lesser boiling point product will produce first than the lesser product. So we now understand the distillation column. So let us just explain briefly the reflux. Like I said, the reflux is liquid return to the condenser. Liquid return to the column from the condenser. So like I explained, returning liquid to the column from the condenser. So the liquid that comes from the condenser, remember that the condenser splitted the condenser converted the vapor to liquid. So the liquid that comes from the condenser, so it's splitted into two and return to the column. That is our reflux. And our reflux have a formula which is equals to liquid return as reflux all over distillation product. So you can do more research on how to calculate our reflux ratio and how to calculate our number of stage using McCabe TLIP method. So you can do more research on that to understand the calculation of our number of stage. So we have the condenser. Like I said, condenser it cools the top vapor, converts vapor to liquid. The condensed liquid is split into two parts. So I've explained that before. So why reflux is important? It improves separation. It improves separation. It increases purities, and it provides liquid for mass transfer in rectifying section. So now you now understand the meaning of distillation column. So when you get to the industry and see a distillation column, you will now know what it is used and how it is used. If this help you understand distillation column better, subscribe to Petrochemical Diary for more refinery and petrochemical engineering breakdown. Please subscribe to the channel, like the video, and then share it to have more petrochemical content. Thank you for watching.